चलिए आज हम लोग रियल नंबर क्लास 10th का कुछ प्रॉब्लम देखते हैं। पहला प्रॉब्लम जो है वो बता रहा है कि व्हाट इज द वैल्यू ऑफ r when a is equal to bq plus r, then the value of r must be greater than or equal to 0 and less than b. Then the option number C is correct. Now proceed to the next question. For some integer m, every even integer is of the form either m plus 1, 2m or 2m plus 1. Here the first option is m. This may be either even or odd. M plus 1, it may be also even or odd. Now the option C is even, and 2m plus 1 is either odd or even. So the correct answer is C, 2m. Now proceed to the third question. Euclid's division algorithm is based on, there are 5 options is there. The first option is correct, that is Euclid's division lemma. Now move to the fourth question. Again, there is some integer q. Every odd integer in the form 2q may be even, q even or odd, and 2q plus 1 is odd, and q plus 1 may be even or odd. So the correct option is C. Now move to the question number 5. r0 and 1 is the only value of the remainder r when any positive integer divisible by 3. No. If any number is divisible by 3, the value of the remainder should be 0, 1 and 2. So the correct option is no. Now move to the next question. That is question number 6. So that any positive integer is of the form 3q, 3q plus 1 or 3q plus 2. Here, this number is divisible by 3. Therefore, let the positive integer b is equal to 3. Then the first number will be 3q plus 0, 3q plus 1, 3q plus 2. So the correct form will be 3q, 3q plus 1 and 3q plus 2. Now move to the next question, that is prove that odd positive integer is either form of 8k plus 1 to be a perfect square. Since it is to be proved the perfect square, let the number a will be 2p plus 1. Then a square is equal to 2p plus 1 square. On solving, we get 4p under bracket p plus 1 plus 1. Let p plus 1 is 2k. Then 4 into 2k plus 1 is equal to 8k plus 1. Hence it is proved. Now go to the next question. That is so that either of the number n plus 2, n or n plus 4, only one is divisible by 3. First we consider the number divisible by 3, b is equal to 3. Then we get the number either 3q, 3q plus 1 or 3q plus 2. Now we will put the value in n, n plus 2 and n plus 4. We saw when we put n is equal to 3q, then 3q is divisible by 3, but 3q plus 2 and 3q plus 4 is not divisible by 3. When we take n is equal to 3q plus 1, then n, that is 3q plus 1, is not divisible by 3. 3q plus 1 plus 2, on solving we get 3 under bracket q plus 1. It is divisible by 3. And third, when we put the value in n plus 4, we get 3 q plus 1 plus 2, and this is also not divisible by Now we take value of n 3q plus 2 and put the value n plus 2 and n plus 4. Again we get 3q plus 2, that is not divisible by 3. 3q plus 2, 3 under bracket q plus 1 plus 1. Since remainder is 1, it is not divisible by 3. But when we put the value of n as 3q plus 2 in n plus 4, we get 3q plus 2, it means it is divisible by 3. Now we move to the next question. Prove that product of two odd numbers is of the form 4q plus 1, 4n plus 1, 4n plus 1. Let's assume the number (4h plus 1) and the another number is 4k plus 1. When we multiply both numbers, we will get 4n plus 1, where the value of n is 4hk plus h plus k. Hence, the product of two odd numbers is of the form 4n plus 1. Now move to the next question, that is question number 10. If a and b are odd prime numbers, then show that a square b square is composite. It means to be any number composite, it must be expressed as a product of primes. Let the value of a square minus b square is equal to a minus b and a plus b, and let the odd number be either 2k plus 1 or 2h plus 1. On simplifying, we get 2 under bracket k plus h plus 1. It means there is two factors, 2 and k plus h plus 1, and it is composite. And the next question number 11. Find the HCF of 210 and 55 and express as 210 into 5 plus 55y and then find the value of y. On using absolute division lemma, we get the HCF of 210 and 55 as HCF 5. Now we go on proceeding from 5. We get the value 210 into 5 plus 55y. Now we put 55y is equal to 5 minus 210 into 5. On solving, we get the value 19.